Welcome to the guide for creating allograph images with 3D source files. In this edition, we'll go through the creation of an allograph print from a 3D modeled scene. We'll also cover the process of sculpting a custom elevation file in ZBrush. To start with, render out a 16-bit TIFF color image. In Photoshop, convert it to grayscale and consider the tones and what they will give you in elevation at this point. If possible, render out each element of your image separately, if it needs to be elevated from the surrounding. The goal here is to have, for example, the water ripples as a complete layer, so there are no gaps under the foreground reed elements. Later, when softening the edges of the reeds on the layer above, we need to have wave pixels underneath the reed edge to blend to. After converting the image to black and white, the frog body does not follow logical gray tones in terms of elevation, and the resulting gray tone of the waves will not produce a smooth undulating surface. In this case, it's necessary to create a custom wave gray tone independent of the color pixel values. Simply apply a gradient to the 3D object and render out a new element. Unlike with the frog, this will work as there are no hidden sides to apply the gradient tone. It could also benefit with a gradient extending to the horizon. The gradient will gradually lift the water ripples up from the horizon to a high point at the bottom edge of the image. Add a black to white gradient layer over the water ripple layer, with white being at the horizon and black at the bottom. Change the blend mode for the new gradient layer to overlay to add the values of the pixels onto the layer below. The same technique is used to taper the sky to the horizon, but next up are these reeds. Out of all the reeds, these are the closest, and therefore will be the darkest. Take a separate render of each element and derive a mask to isolate each piece that needs to be elevated separately. If need be, apply a mask gradient layer that is lighter than the surrounding elements to help blend the layers together. It's possible to render out your scene with a 3D fog effect to generate all the elements. This creates a fog of gray tones, getting lighter as they recede from view. Keep in mind that you'll lose control as to what is the lightest and darkest, and it'll also create varying levels of walls which will need masking and blurring. For background elements low in elevation, this could work. We'll continue with the Photoshop technique, as that allows the most customization and tweaking. Using a mask, isolate the leaves according to the elevation needed. With the Select and Mask option, balance the position of the blur level on the mask. You may also need to apply a Gaussian blur to the edges of the rendered layer. It's a delicate balance to find just the right amount of blur on the foreground and background. Apply a levels adjustment layer to reduce the white edges to a gray tone, matching the background. Reuse the mask on a gradient layer to apply a gradated lighter tone to blend these dark tips closer to the surrounding waves. This is also a good technique to create basic layers like the mid-level set of reeds. Feathering the gradient's mask will blend this element against the background. The elevation-only text insert is an example of adding new elements that weren't in the original image, and can add to the story inherent in the original composition. This could be a 3D rendered gradient element, or 2D like here. It has the layer style outer glow applied. In this case, the text layer was rasterized and a Gaussian blur applied to create a softer blend down to the sky tone, as the outer glow did not completely eliminate the wall effect. The sun's rays have an outer white glow in the layer styles to blend the ray edges down, and a large soft edge white circle to push a sky tone down, which allows the sun shape to rise in the center. The frog character is separated into body, arms, and leg layers. Each has a layer mask that has been feathered to soften the transition to each other and the background. Unfortunately, it's not as simple as just rendering out a depth map, as you need all edges of each element to gradate down to white from the camera's point of view. At that point, you can edit these edge tones to match what's underneath. Think of it like using a 3D object to render a 2.5D print. To better illustrate, here's a sphere with color applied, a three-dimensional object in the same way the frog is. If a grayscale gradient is applied and rendered out, the gradient goes from black to dark gray at the edge, rather than white. As the white point of the gradient is in this hidden area here, the farthest point of the object from the camera rather than at the edge where it's needed. Take this into consideration when preparing 3D objects and either applying a gradient or using a depth map. For the floating lily pads, it's just a matter of isolating each onto a layer with a mask and applying a gradient of tones just darker than the surrounding pixels so that the leaves are elevated above the highest point of the waves. Here's a variation for the ZBrush process for custom elevation. In your 3D app, create a polygonal plane with the same aspect ratio as your color image and center it to the XYZ origin. Apply UVs and ensure the color image is aligned correctly to the surface. Create an orthographic projection camera. Also centered at the origin, and set the render output to the same dimensions as the color original. Adjust the camera lens to align with the edges of the plane. Export the flat plane object and import it into ZBrush using the FBX format. Depending on your 3D app, in some cases, if you import an FBX with a texture map applied, it will import into ZBrush and look correct, but then a displacement map will show as flipped. So ensure you have the correct UVs before going any further. Add a layer for displacement and a second one for sculpting. If you use an external grayscale image to displace the surface, you may need to flip the UVs for it to show correctly, and then back again for the color to render properly when exported. A 16-bit TIFF or PSD will create a banded effect, so make sure to use a 32-bit EXR image to generate a smooth displacement surface. Once you have the sculpted surface complete, export the object as an FBX mesh back to your 3D app. Apply a procedural grayscale gradient shader to the imported object with black assigned closest to the camera and render the camera view. The resulting rendered image will now be your 16-bit grayscale TIFF, ready for further work in Photoshop or straight to print. Depending on how much sculpting is done, you may need to assign the original color image to the 3D object and render out a new color file, as the shifting of the sculpted surface may change the 2D alignment of the color pixels on the polygonal surface. To see how the effect is progressing, we can save out the color and grayscale 16-bit TIFFs and generate a point cloud preview with the Arius image to point cloud converter. View the preview point cloud in an app like Cloud Compare and iterate until you're confident the elevation is working without issues. With these techniques and your skills in Photoshop, you should have no problem generating a working grayscale file for your image. For further tips and techniques, check out the other videos on this channel.